So let's talk about proactive event-driven security. In the realm of modern cybersecurity, staying ahead of threats requires a proactive approach that goes beyond traditional and reactive methods. The combination of F5 Big IP's advanced web application firewall and event-driven automation with Ansible automation platform is helping our joint customers in achieving this proactive security stance. Hi, my name is Matt Mabus. I'm a Senior Solutions Architect at F5, and I want to show you a lab demonstration we have created to take your security to the next level. Before I dive into the demonstration, let me tell you what you're going to see. We're going to have an application front-ended by the F5 Big IP for external client access. The application will send monitoring and telemetry to Elasticsearch and Kibana. From there, we'll have a watcher that Elastic will trigger a webhook based on our company's criteria. That webhook will trigger Event Driven Ansible to launch a playbook within Ansible automation platform to apply our security policies. In our specific use case, it will be to block IPs given to us from Elasticsearch, and then it will apply those security policies back to our existing application that was being front-ended. The only thing that we are going to do after it's all set up is emulate a bad contender. And now we're going to move on to the demonstration. So here's my lab. I have a big IP with the advanced web application firewall, and then I have this client jump host. And what that allows me to do is open up a Firefox instance that allows me to connect to my Ansible automation platform GUI, as well as the Event Driven Ansible GUI. Then I also have a DVWA application that's being presented through the big IP. So let me log in there. And we can go ahead and look at that. So the address should match up. If I go under the virtual servers, you'll see that there's this 10.150.100 address that if I go over here, you can see that this is an external client kind of connecting to that application. And then if we go back into the lab, I have three different subnets. There's VLAN A, VLAN B, the management subnet. Then I have the Kali Linux instance that allows me to run my scanning vector that kind of emulates me doing naughty things from different regions that are a part of my event-driven security. The node 1 is where our Kibana and Elasticsearch instance is running from, where all of our monitoring is going to. So this is our observability node. And then node 2 is hosting the DVWA application that is being presented to the big IP. So that's the web node. Then I have two instances, one for RHEL 9 for the Ansible automation platform installation, and then the other one is for the event-driven Ansible installation. So there's two server instances for that. So that's the lab. Jumping back over to it, I'm going to go ahead and log in real quick to the Ansible automation platform and the event-driven Ansible instance. If I go into my projects in my Ansible automation platform, you can see I already got a demo project set up for it, which also contains the Git repo for what we'll be doing. This is public right now. You can go to the F5 DevCentral and pull up our code. So if you wanted to take a look at the instances of the code, you'll see that we have our Elastic folder here that contains our JSON files for our watchers that we will enable later. We also have the playbooks that the Ansible automation platform will be using to execute code with, and I'll show you the templates that we've already created for that, as well as the rulebooks that we'll be using for event-driven Ansible to trigger those playbooks. And all of that code is available on the F5 DevCentral GitHub repository. I do have an execution engine that I've already imported. This one is one that we store on Quay. It's one I've used before for a lot of the demonstrations I use for our Ansible 101 and 201 labs. So this execution environment I've used, it just contains the F5 Big IP modules. The other thing that I wanted to point out as part of the project is that we're using the execution environment in the project, so I don't have to apply it to the templates themselves as I'm building them. So I have three different ones here. I have the AWAF blocking, which is allowing us to modify the existing ASM policy that's tied to the application. So this virtual server here, if we go into it, we can see under the security policies that there is an active WAF policy associated to it, or a security policy that we've enabled to it. And also that there is the logging profile that will submit the telemetry of what's going through that application at the time and sending that over to our Elasticsearch instance. as part of our event-driven security, we have this blocked IPs playbook, which is going to take in the payload that's given to it from Event Driven Ansible, which Event Driven Ansible was given that payload information from our Elasticsearch engine, which originally came back from our big IP. So it kind of is a full circle. So the logging information from the big IP is getting sent over to Elastic. Elastic's going to send that payload information through the watcher into Event Driven Ansible. Event Driven Ansible is going to trigger the playbook that I tell it to do based on the watcher, and then it's going to call Ansible Automation Platform and give it the payload with the IP addresses that I want to block, and then it's going to execute upon that. In the template, you can see here, there's one thing I want to point out. To get that payload into the playbook, you need this prompt on launch tick box ticked on the variables section. This is something that I had to learn the hard way. If you don't have that box ticked, then event-driven Ansible's variables will not get passed through to Ansible Automation Platform. Now, jumping over into event-driven Ansible, I also have that project set up here for the event-driven Ansible demo. It's using the same repository that I was just pointing out before in this Git repo. It's just using the rulebooks as part of the webhooks that we'll be doing it. So I'm going to go ahead and create that rulebook real quick. So I'm going to just call it EDA demo. There's only one project in here. It is easier for the separation. If you select the project, you can see the rulebooks. If you have like hundreds of rulebooks or something like that, you may want to select the project that's the rulebook that you're trying to execute is associated with. But you don't have to do that initially. It would show up here without selecting the project, but I just still do it just to make sure that you're getting a consolidated list rather than a big list. So I'm going to select the block IPs YAML rulebook, and my decision environment, I'm just going to leave it as the default decision environment, the restart policy set to always, and I don't need to add anything into the variables. If I wanted to, I could, where if I wanted to inject additional variables, I could, but I don't need to in this case. So I'm just going to leave everything pretty much on the default on that and make sure that the tick box is enabled. I'm going to go ahead and create it, which will then start the rulebook activation, and you should see it change from a starting state to a running state here in just a few seconds, and then the code will be active. So now I've refreshed it and we can see that we're in a running state. So we have a number of rules as part of it. We can click in there, we can see everything that it's doing, but we know the activation status is running. So now we have a webhook listener ready. So what it will do is when our watcher code from Elasticsearch triggers an event, it's going to send to a very specific webhook on this machine. We can go in and actually take a look at the rulebook real quick. It's a very simple rulebook, but I'm going to just go ahead and show you what it looks like. It's setting it up so that there's a listener on the local host of the system on port 5000, and if it receives a payload message of Ansible, please block some IPs, then it's going to run a job template called block IPs using the organization of default. Well, this doesn't make any sense to EDA, but because EDA is hooked into AAP, it's going to look for a template called blocked IPs. So if we go back to Firefox, we go back into our templates, there is a template called blocked IPs, and its organization is in the default organization. So the code is looking for that specific template in AAP to run if this criteria condition is met. So what will happen is if a webhook is being sent to it from a source, it doesn't matter if it's Elasticsearch, it could be any other monitoring tool. Heck, you could send it as a postcode directly to it with the payload inside of it. As long as it came in under event payload message, it would show up and start executing the code. Now, I'm not saying it would run the code correctly, but it would execute the code. We set up an Elasticsearch watcher, which has this blocked IPs JSON. And inside of it, it's got an interval of every 3 minutes. It's going to check to see if something matches the criteria of its code to then execute a webhook. So you can see at the bottom of it, we have this webhook set up, and it says that message is Ansible, please block some IPs. So that's a match to what EDA is expecting when this code triggers. And then we're also sending along this payload. This payload is part of this transformation, and it's going to utilize the monitoring data for its search request. And all it's doing is looking through all the monitoring and the database that it's got at this time, anything that's coming in that matches a specific criteria. There is one other caveat. I limited its size so that way I didn't get like thousands and thousands, but you can do this. But you'd have to make sure that your interval is separated out a little bit more so that way your executions don't overlap with each other. It's just nicer that way. So I just limited it down to 20 out of the execution, but it's also trying to match a criteria. If any IP addresses come in from Russia, North Korea, or China, I don't want anybody accessing my website from those IP addresses. So it's going to trigger based on that criteria. When it does, it's going to take the source IP from that connected client and it's going to insert it as part of the payload that's going to be sent off here. So this payload is a part of this transformation, which is gathered from data that is collected and searched through. So as those IPs are coming in, it's going to find them, it's going to store them into a payload that, and again, because like I said, I limited it to 20, it's going to give me the first 20 of this list, and it's going to submit those IP addresses as blocked IPs for my code. And the code that will run in Ansible automation platform is this playbook code, which is blocked IPs. What it will do is it will take the payload, it will create an array that allows me to use it inside of my Ansible playbook, and then I'm using that data to apply it to the existing WAF policy, making sure that those IPs are blocked. And that's all this code is really doing. If I go ahead and try to run this code, you can see that I've already got Elastic here. Elastic. I'm going to jump into it real quick. If I go over into my stack management where my watcher code is, you can see that I've already pre-set up this watcher code, and you can see that nothing has triggered it yet. I've got it all set up, but it failed to fire originally because we didn't have that watcher set up. But now it's monitoring, and you can see it's happening every 3 minutes. So nothing really is going on. There's no triggered states that are going on right now, but it knows that the watcher and the webhook can connect to each other. And so it's ready to go. So if I double check everything, we can see that our templates here, we have our blocked IPs, nothing, it's never been run. If I go into my rulebooks, we can see that it's running and waiting. And then my application here, it's in its vulnerable state. So I should be able to see when I run that scanning tool, Necto, that it's going to come up with some things. So now I'm going to go into my Kali Linux instance, and then I'm going to go execute some code that kind of emulates that attack. So what I'm going to do is I'm going to paste this command here that I have. It's basically going to go at the 10.150.100 host, which is going through the big IP, which is being monitored. So I'm going to go ahead and run this code. What it's going to start doing is it's going to start running a scan against the existing virtual IP that I have out there, that 10.150.100. You can see that it's detecting all sorts of stuff already. It's saying that I've got some vulnerabilities here, I've got some vulnerabilities there. And basically what's going to happen within the next 3 minutes, that the watcher will eventually trigger. So once it triggers, it's going to then trigger the code execution for EDA. The EDA is going to trigger the code execution on AAP. And look, we start seeing it firing already. So kind of hit the timing just right. If I go in here, I want to look at, see what it found, because I find it interesting. So if I go down here, it can show me some of the login criteria. You can see that watcher is looking for things, and you can see that, hey, I found something coming in. And if I look at the country codes of the regions, it's saying I found something from China, and it goes a lot. Like I said, you can get hundreds and thousands of it, but I limited it down to that 20 selection. But now you can go down here and see the payload that I submitted. So it sent a webhook to the Event Driven Ansible over port 5000. It sent the body with that, please block some IPs, with the payload information, just like we expected it to. If I go back to my Ansible automation platform instance, I can go into and see blocked IPs was just run. If I go in and take a look at my job real quick, you can see that it ran successfully. If I go in here and it says I have this payload, because I kind of enabled some of the logging. So we can see that the payload information made it from the watcher all the way to Ansible automation platform. If I go into my big IP, what I can do is if I go into my IP address exceptions list, I should start seeing those IP addresses that were being blocked. So if I wanted to actually verify that these addresses were the ones that I got from the payload, I could actually compare it to some of the ones that we had here. So 39.18 ends in 34.223. If I go over here, and if I look for 34.223, this one here matches 39.180, 34.223. So this demonstration has proved that we can use Event Driven Ansible with our monitoring tool to create automated security, proactive security. So all I did was I had my big IP being monitored by Elasticsearch and Kibana. And then from that monitor, I created my watcher saying I needed to do something based on my criteria, my company's criteria. And when something matched what my company said I don't want to happen, which in this case was if I saw things coming from China, North Korea, Russia, I would start blocking them. In that case, I submit that payload information into a webhook, which goes into Event Driven Ansible. Event Driven Ansible took that information, followed my Rulebooks commands, which were, hey, I found what you were looking for, that webhook came in, I need to execute code on Ansible Automation Platform. Ansible Automation Platform had my playbook ready for it, and it executed its code. So now we get to see the full circle of how event-driven security is being built. And in addition to the security-focused event-driven Ansible work that we do, you also might want to check out our hands-on labs that we teach regularly that are focused on Ansible and Big IP. And if you have questions about this lab or anything else Ansible related that we do, feel free to reach out to us at F5. Thank you for your time.